right, good morning, everyone. I'm Janine, this is Suraj, this is Nishant. We all teach data science classes at large universities with a lot of students, and we want to talk to you about our workflow for how we do that. So the title of our talk is Rise and Shine. Raise your hand if you've ever heard of Rise before. Okay, not too many. So hopefully after today, you kind of know what it does and you might try adopting it in your classes. We use Rise because it checks a lot of the boxes for our ideal lecture delivery. We want to be able to have static content like formulas and things on the slides. We also want to be able to do some live coding so students can see our process of how we get to our solutions. And we want to be able to annotate things, maybe write out proofs or formulas or draw on pictures or something like that. So we need a lot of different things like in our lecture slides, but it needs to also be easy to maintain so we can pass our materials on to the next instructor or keep the same content from quarter to quarter. And students need to have access to content in a way that's easy for them to use. So Jupyter is kind of behind our system for how we create our lecture slides. And we mostly use the extension Rise along with some other open source tools to make this happen. Okay, so basically we create a single source notebook that has all of the content that we want for our lecture. And we use the Rise extension to turn that notebook into a dynamic slideshow. So right now this looks like a slideshow, but we're actually presenting from a Jupyter notebook. So all of this, okay, there we go. Like all of these slides are actually just in a notebook and there's little descriptions of how I want it to appear and how bullet points should come up gradually and things like that. Okay, so we can do the basic stuff you would want to do in any Jupyter notebook, right? Like formulas and images. We've also kind of pushed the limits of what you can do to replicate some stuff that you might have in a typical slideshow presentation, like activities or questions that you want students to answer. So maybe you ask this question in class, is a hot dog a sandwich? And you want students to discuss it in pairs, and then they should also be able to see your solution after the fact. So we have this drop down, which is just done with HTML behind the scenes so that they can reveal the solution. And we get the nice colored formatting through CSS. Okay, another thing that sometimes we want is more rich animations. Like basically Rise can make bullet points appear one at a time, but maybe we want to illustrate a more complicated process. So this is an example of an animation that we actually made in a Google slideshow. And we're just importing that Google slideshow as an iframe here. So earlier in the notebook, we defined a function called merging animation that just simply produces this iframe and allows us to click through the merging animation. But students don't need to see all of the code for that, so we have that in a code cell at the beginning of the notebook that we skip. And sometimes if there's a lot of stuff like that, we might even extract it away into another file that we just import, so that when a student opens the notebook, they're not assaulted with a bunch of complicated code first thing. Okay. Okay, I'll pass it over to Nishant.
Yeah, and so we can use iframes to, for example, ask students polls. If, as an instructor, you want live feedback using clicker kind of questions, one thing you can do with an iframe is also embed, for example, a snippet of a Google form. Students can live click and interact with these and share their responses for how many faces a rhombicosidodecahedron has. Any guesses? 20? Okay, this one's actually 62, which is crazy. So again, this is an example of an interaction modality in a lecture you might want to have, and the sort of thing that we can embed into Jupyter because of its rich capabilities for Markdown and HTML. Yet another thing we can do, right, is use IPy widgets. And because these are just regular code, we can embed things like, for example, an interactive illustration of the mathematical definition of convexity. And we can, for example, move around points and automatically construct these animations and use them seamlessly during lecture and build these things in code as interact widgets. Naturally, of course, one reason to use Jupyter is to seamlessly blend sort of static content, multimedia, text with live coding. But when you're live coding during lecture, you don't always want to have to write everything from scratch. And so, maybe some of your imports, some of your definitions, you want to leave existing and you want to automatically construct the blanks. This might be useful for consistency between multiple instructors or just to make sure you don't forget what you actually wanted to live code during class. So one key step in our workflow is to use otter-grader to automatically add the solution markup, and then extract out and create those blanks automatically using the Otter workflow. Now, this is usually something that's meant for constructing assignments, but we can use this for lectures as well. And so in this case, for example, we're sampling rolls from dice at random and taking the mean, but you can automatically construct this code with the blanks and hold on to these solutions so students can refer to them later.
In addition to running code and interacting with widgets, you may want to occasionally annotate slides with, say, markup. And there's a built-in tool in Rise to allow you to do that. There's a chalkboard feature. But in addition to that, one tool that we've found to be useful, sorry, there's a lot of things going on here, is the macOS Presentify tool, which adds colors and undo, redo, and that sort of thing. And if you happen to be on macOS, you can sidecar your laptop screen to your iPad screen. And so then when you annotate, I don't have someone nicely holding my iPad for me, but then I can annotate without having to use my computer's mouse or a touch screen, and I can use my iPad to take neat annotations. And one workflow I've found to be useful is if you get in the habit of quickly taking a keyboard shortcut of your annotations, a keyboard shortcut for taking a screenshot of your annotations. There's a really quick way to compile all of those screenshots into one PDF that you can also provide your students with, so that students who didn't come to lecture, they should come, but students who don't come to lecture can also look at all of those annotations rather than those like whiteboard annotations only being saved for students who happen to come, because sometimes recordings don't capture those well. So our workflow that enables all of this to happen, again, as Janine mentioned, starts with one source notebook, which becomes really easy to maintain from semester to semester and from instructor to instructor. That's where we plan all of the formulas we want to show students. It's where we plan the sections of the lecture that are going to be live coded versus already presented to students. And we pass that source notebook through a script that we've developed that uses otter-grader and nbconvert to create a menu of options that students can use to interact with the lecture with us in class and then afterwards. So one asset we create for students is an HTML file, and we've seen lots of students opening these HTML files on their iPads in lecture so that they can scribble along if they'd like. And we post that on our course website so students can access that with all of the code already in there and already run so they can see the outputs of graphs. They can do that without needing to, say, download, pull anything from Git or open something on a server. That's just really easy for them to access. But for students who do want to follow along with us in code, we provide them with two versions of our lecture notebook. We'll give them a blank version, which will have those ellipses wherever we want them to live code, and in lecture, we will use that blank version ourselves, and we will also provide them with a filled version with all of the things we are going to write already there. A common complaint I would get a lot in lectures that I type too fast, so I was like, okay, you know what? Here's the filled notebook, so you can see what I'm going to type, and you can also refer back to it later on. And that way, students really have, the choice is really up to them. They can interact with lecture content however they'd like, and all of these assets are posted for them to refer back to, along with that annotations PDF that we create as well. So we have used parts of this workflow at multiple universities. There are a few websites here that you can go to right now and look at live versions of these things. DSC 10 is the introductory data science course, similar to Berkeley's Data 8, taught at UCSD. And practicaldsc.org is a class in a similar spirit that we teach at Michigan. And you can see examples of all of these sorts of things. And if you have questions with how to adopt any piece of this workflow, because this is not like one tool that we built, this is like a hodgepodge of various things that the community built that we're just using and have been working well for us. If you have questions on how to adopt any piece of this, my email is up here, but feel free to approach any of us after this, and we'd be happy to show you what we know.